Namaste everyone. Welcome back to our DSA series. Today we are solving LeetCode problem 74, search a 2D matrix. This is a medium level binary search problem. The problem gives us a matrix with two important properties. First, every row is sorted in non-decreasing order. Second, the first element of every row is greater than the last element of the previous row. We are also given a target value. We need to return true if the target is present in the matrix. Otherwise, we return false. The required time complexity is O of log m into n. So we need to use binary search. Let us first understand the main intuition behind the solution. Suppose the matrix is this. 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. Each row is sorted. Also, after the last element of one row, the next row starts with a larger element. For example, 10 is greater than 7 and 23 is greater than 20. Because of this property, if we read the matrix from left to right and top to bottom, the complete sequence is sorted. The sequence becomes this: 1, 3, 5, 7, 10, 11. So it becomes this. Let me write it down: 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. So even though the data is stored in a two-dimensional matrix, we can treat it like one sorted one-dimensional array. The important point is that we do not need to create a new flattened array. We will only imagine the matrix that the matrix is flattened. Then we perform normal binary search. Suppose the matrix has m rows and n columns. The total number of elements is m multiplied by n. So our search space starts at index 0 and ends at index m multiplied by n minus 1. Now the question is, if binary search gives us a one-dimensional index, how do we access the corresponding value inside the matrix? So this is the question. If binary search gives us a one-dimensional index, how do we access the corresponding value inside the matrix? So we use two simple formulas. The row is equal to the index divided by the number of columns using integer division. So the row is equal to the index divided by the number of columns using integer division. So integer division is double slash. It gives us a integer value less than or equal to the quotient. The column is equal to the index modulo the number of columns. So in Python we write row equals mid double slash columns. That is simply if I write here, it is row equals mid double slash columns, and column equals mid modulo columns. Let us understand this with an example. Suppose the number of columns is 4 and our middle index is 6. So let's define it as matrix is equal to 1, 3, 5, 7. Then comes 10, 11, 16, 20, then 23, comma 30, comma 34, comma 60. So this is our matrix. Now it has m equal to number of rows, that is 3, and n equals number of columns, that is equal to 4. Our middle index is 6. So mid equal to 6, let's say. The row will be 6 double slash 4. So row equal to 6 double slash 4, that is equal to 1. And column will be 6 modulo 4, that is equal to. So index 6 represents the matrix of 1 and 2. The index 6 is equivalent to a matrix of 1 cross 2. The value at matrix of 1 and 2 is 16. So it is not like that. It is like matrix 1 comma 2, and value at this is equal to 16. As you can see here, it is 16. This allows us to perform binary search without actually flattening the matrix. So what we are doing is a very extremely simple thing. We just flatten the matrix. We say that it is like this, equivalent to a single dimensional array. Now we need to get if I have found that mid is equal to number 6, 1, 2, 3, 4, 5, 6. Okay, so I am looking into this array. So my left will become equal to 0, and right will become equal to 3 into 4, that is 11. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 elements are there, so my right is 11. So my mid will become, let's say, equal to 6. Then it is the 1, 2, 3, 4, 5, 6. So I am saying right equal to 12. I am not marking it as index, but it is 1 to 12. So I think it is not the convention that we are following. Let us understand when we write the code. First, let us understand the algorithm. You can, as of now, you can think like we can convert the 2D array into 1D array, and then we can convert the indices into rows and columns. Exactly how they we will discuss again. Algorithm is simple. We first set left equal to 0. We first set left equal to 0. Then set right equal to m star n minus 1. Then calculate the middle virtual index, convert it into row and column, convert the matrix value, compare the matrix value with the target, and continue binary search on the appropriate half. Now let us write the code. So this is the code. We start by creating the solution class. Inside it, we define the search matrix function. The function receives the matrix and the target. First, we calculate the number of rows. Rows is equal to the length of the matrix. Then we calculate the number of columns. Columns is equal to the length of the matrix at index 0. Now we initialize the binary search boundaries. So left is equal to 0 and right is equal to rows and multiplied by columns minus 1. Next, we run a while loop. The loop continues while left is less than or equal to right. Inside the loop, we calculate mid. Mid is equal to left plus right minus left divided by 2 using integer division. Now we convert the virtual one-dimensional index into matrix coordinates. So row is equal to mid double slash columns. Column is equal to mid modulo columns. Then we access the value. So how can we convert? Let's say our index is any random index. We have converted this into this form. So how we get the row and column from this index? Let's say there is an index I in the 1D array. Question is what does it correspond to in the 2D matrix? So there is an index I in the 1D array. What does it correspond to in the 2D matrix? So how can we find that? Suppose my index I was equal to 0. I'm simple like why to memorize some formula. Let's understand how we derived it. If my I equal to 0, then it will correspond to 0 comma 0, right? And if my I is equal to 1, then it corresponds to row 0 in column 1. If my I is equal to 2, then it corresponds to row 0 in column 2. I equal to 3, it corresponds to row 0, column 3. Now I equal to 4, it corresponds to row 1 now and column 0. So what has happened? So this value, the first row is equal to I and so let's say column is easier to identify. Column equals to column can lie between 0 to 3 only. So I can, if I do I mod row, if I write this formula I mod row is equal to I mod m, number of rows is m. So it can only lie between 0 and to 2. So I need to I mod n so that it lies in any of the column. Number of rows is m and number of columns is n. So if I do I mod n, the values lies between 0 to n minus 1. So that's what we are doing, mid-mode columns. And my regarding my rows, so row can be, let's continue this. So I equal to 5, this becomes equal to 1 comma 1. So let's go to I equal to 8, then it becomes 2 comma 2 comma 0. For 6 it becomes I 1 comma 2. For 7 it becomes 1 comma 3. And for 8 it becomes 2 comma 0. So what we are doing, for I equal to 12 it will become 3 comma 0. So we are simply doing integer division. If I do I double slash m, because it can only lie between I double slash n. So its maximum value can be max value less than m, because the total number of elements in this 1D array will be m star n. It will be m multiplied by n. That is 12 elements are there, and we are dividing by n. So its max value can become less than m only. So that's the formula for rows. So this is just intuition that you can take examples and try to figure out what is the formula to get the 2D indices, 2D matrix indices from 1D array index. So whenever you are stuck, just take simple example and then try to figure out what to do. So we have defined row, column, and the value equal to matrix row, comma, column. After that, we check if value is equal to target, then we return true. Simple binary. So if value is less than target, then we update left. Else we update to the right. Finally, if loop finishes and target is not present, we return false. Otherwise, if it is equal to target, we return true. Now let us perform a dry run. The matrix is the same. This is our matrix, and target is 3. So we have 3 rows and 4 columns. So the total number of elements is 12. Left equal to 0 and right equal to 11. In the first iteration, mid becomes equal to 5. Mid equals 5. To convert index 5 into matrix coordinates, row is 5 double slash row is equal to 5 double slash columns. So row becomes 5 divided by double slash 4, that is equal to 1. And column is equal to 5 mod. The formula for column is 5 mod columns. Columns number of columns is 4. That is equal to 1. So the value at matrix 1 and 1. This value is equal to 11. So matrix 1 1 is equal to 11, and this value is greater than target. So we update our right will become equal to mid minus 1, because it is greater than target. So right becomes mid minus 1. Right equals 4. Similarly, then left and right will keep on updating. So this dry run you can complete on your own. Let us run the code now. Let us submit it now. Okay, so all the discussions pass. Now let us discuss the time complexity. So time complexity is O of log m multiplied by n, because our search space is of size m star n, and our space complexity will be O of 1 because we don't use any extra array or any other structure. We only use a few variables. We do not create a new array. Now let us look at some common mistakes. So the first mistake is actually flattening the matrix into a new array. So we don't need to do this. Simple math can help us solve uh, solve this problem of converting the index of a one-dimensional array into two-dimensional matrix. And this would require an O of m into n additional space. It is unnecessary. We only need to treat the matrix as a virtual flattened array. The second mistake is using the number of rows while converting the index. For converting the index, we must use the number of columns. The row is mid double slash columns and the column is mid modulo columns. The third mistake is setting the right pointer incorrectly. The final valid index is rows multiplied by column minus 1. The fourth mistake is using a normal linear search. That would take off m into n time and would not satisfy the required complexity. You may also think about starting from the top right corner of the matrix. That approach would take O of m plus n time. It would work for some sorted matrix problem, but this problem specifically asks for O of log m into n. So binary search is the better solution. Let us quickly recap. So the complete matrix behaves like one sorted array. We perform binary search on virtual indices from 0 to m multiplied by n minus 1. For every middle index, we convert it into a row and column. The row is mid double slash columns. The column is mid modulo columns. Then we compare the value with the target and continue binary search. The final time complexity is O of log m into n, and the space complexity is O of 1. That's the complete solution for LeetCode problem 74, search a 2D matrix. Try coding it yourself before submitting. Thank you for watching. I will see you in the next problem.